Yeah, my name is Bill Siegle. I am a longtime practitioner, if you will, of the arts of semiconductor technology in general and lithography stuff in particular. I've been retired for the last 7 years or so, 7 or 8 years, after a career of 25 years at IBM and 15 years at AMD. But since then I've done some consulting work, mostly board work, and currently I'm on the board of ASML. There's a major sea change in what I'll call cooperative efforts between companies and across the industry. And I look at the 1980s as the decade in which that sea change occurred. Prior to that time frame, there was very little cooperation between companies. Between companies and their suppliers, yes, but not between companies that would normally you would view as competitors. That changed in the 80s. And now you have a wide variety of cooperative ventures, either companies working together to fund research in advanced problems, or companies working together to just share the development cost of new technology. That particular change, I think, has been a major sea change in the industry, and you see it at this conference too. You look at the number of jointly authored papers, there are companies working together across disciplines, and in some cases companies that might be competitors. It's really astonishing, and I consider that the biggest single change that I've observed over the last 30 years, let's say. If you look at leaps versus incremental steps, is you have both things going on all the time. A perfect example might be the current efforts on EUV. EUV represents a leap, but while EUV is getting ready for production, meanwhile incremental advances in 193, multi-patterning, now directed self-assembly being talked about as a way to simplify some of the complexities of multi-patterning. You have all that stuff going on at the same time too. So it's part of the vitality of lithography business is you have this smorgasbord of incremental improvements and big steps that are underway at all points in time. They don't all succeed. I mean, there's a lot of failures, I hate to use that word, but let me say dead ends along the way. But that's part of a sign of the vitality of the technologies, that people are willing to expend effort and to explore new routes that may or may not prove fruitful. EUV is a tough technology transition. All of the wavelength transitions are difficult. This one's more difficult than others because there's more dramatic changes in some of the associated infrastructure. But that is a big deal to the semiconductor manufacturer. The ability to get back to single exposures instead of double patterning, triple patterning is a large economic factor to the industry, and is an ingredient that will play a big factor in that continuing economy of scale and lower cost per function going on into the future. So, if EUV isn't there and we're limited to the kinds of things we can do with multiple patterning, I think clearly our progress in staying on Moore's law will slow. We've got to make that transition to EUV, but it's not a given, because there's still enough tough problems to solve there that I think you'll find still a fair number of doubters in the industry as to whether that will happen. But to me, that's a major hurdle that the industry has to get over, and it's getting closer. I mean, I've been pretty close to seeing the rate of progress there, and progress is continuing, albeit not at the pace we all might have liked. But it's got to get there in this next 5-year interval, in my opinion. Progress is getting harder as we get closer and closer to some of the physical limits of microns and molecules. The tasks can seem formidable at times, but one of the things that's always been striking to me is that clever people working together can come up with remarkable solutions or end runs around problems that you would not have anticipated. Moore's law, as some people have observed, is an observation, not a law. And it really follows from the simple fact that each time you can increase the integration level on silicon, or put another way, make a bit or a circuit less expensive, you open up additional applications, and with additional applications come additional business opportunities, and that's the fuel that drives the whole continuous advancement process. As long as cost reduction can be delivered one way or another, that process continues to move forward. That's one of the reasons why you see increased pressure these days on the next wafer size, 450 millimeters, because that's another way to get cost reduction. If it gets more difficult to make advances in shrinking, then you have wafer size as an efficiency to drive cost improvement going on in the future. There are lots of ways to skin the cat.